So for the last video, I'll be talking about my personal project about the Kinect. So to start off, we will go over the class diagram for the Kinect stuff. So I have my Kinect manager over here on the left. That simply is what interacts with the Kinect, and I get information from my Kinect manager so that the only thing that interacts with the Kinect is the Kinect manager itself. Then I have my gesture test manager, which manages all of my single gesture managers and calls them to update and keeps track of what gestures are available so that multiple gesturables can be gesturables, or game objects can register for the same gesture and have the same manager, just like inputable. Then I have my gesturable, which is a new type of game object thing, or a bool, I should say, and then the gesture command, which I've added so that there's not a long callback from the single gesture manager with a string that the user has to test against. Instead, when they register for a gesture, they simply register for the gesture and they give it the command that they want it to activate when the when the gesture is completed. There are three types of gestures that I have available for the user to use. There is a single gesture, a two-step gesture, and a three-step gesture. So the single gesture simply means if your hand is on the right, for example, as long as your hand is over on the right, that gesture is going to keep going off every frame and calling the commands execute, because it is only checking if your hand is to the right. It is not a movement or anything like that. But, for example, a two-step and a three-step is checking if your hand's on the right and then moves to the left. So it's a movement that's going to, when you get to the left, call the execute once, and that's it. It's going to wait for you to go back to the right and then to the left again to call that again. Same goes for three-step, but it would be like right, left, and then back to the right again, for example. So, obviously I have three different managers because there are different tests that go on for each one of those. So to start off, we will go to my gesture test manager. Or actually, to start off, we're going to look at the user stuff so I can show you exactly what it looks like on the user's end. Because obviously the goal for this was to make it usable for the user, so I tried to make it as simple as possible. And I think I actually fulfilled that goal. So the user just has to create a public gesture, and then they make a virtual for how many tests it's going to have, and then to set it up, they simply have an enum for 1, 2, or 3 tests, and then the amount of time in between tests for if it's a 2 or a 3. Also, they push to this joints list what joints they are using down here, and then they set up test 1 and test 2. All of the tests that are in this game are 2 steps because I wanted movements, so they are all 2 steps. They just have a gesture test 1, gesture test 2. Then the user sets up a command. So gesture command. This one is set up to have a pointer back to the game controller, which is just something for the game. And then it has an execute. So when it executes, it calls move to the left on the game object at the top of the list. And if that is true, because this returns a true or a false, it will then pop that off the top of the list. That's just for the game, obviously, but just calls execute. So then the user, for example, in the game controller, there's nothing to add in the .h since there's no callback. So in the .cpp, they simply register for a gesture by telling it which gesture by name, and then the command that they want to happen. And then it will just do it magically whenever the gesture is completed. For deregister, all you need to do is tell it which gesture you are deregistering from. So for that's it for the user, except for loading them in. So in the resources, load all resources, you just need to do load gesture, name it, and then which gesture it is that you've created that you want to be that name. Simple as that for the user. So to demonstrate this game, I'm going to stand up and play it. My cord for my mic is not long enough, so I'm going to put the mic down. The Kinect is going to try to listen to me, but it's going to sound awful, so I'm not even going to bother trying to talk to it. via the mic because I don't have that stuff set up properly. It's just it likes to try for some reason when I connect it via uh, Connect Studio sometimes. So if there's weird static, that's why. But I'm going to demonstrate the game really quick, and then I will come back and show the rest of the code. So as you can see there, when I swiped it, I was pushing the houses away. I'm not very good at my own game, and I kept forgetting that I had set it up for only specific arms. So when I dropped my left arm, I would push down. When I raised my right arm, I would go up. That's why I lost twice, because I was flipping those around in my head. Swipe left was moving from the right to the left with my right arm. Swipe to the right was moving from the left to the right with my other arm. For the swipes from the left to the right, I have to cross my spine, which is at the end. I just didn't move my arm far enough, which is why I didn't call that gesture through. But other than that, I haven't. It works as fast as I want it to. Like I can just flail my arms around and it'll work, which is actually pretty crazy that it registers so much so fast. But like I said before, I showed you in class, but I'm gonna go over it again just in case. So obviously that's the demo game that I created. It's just using gestures, two-step gestures to move houses around. As for my code, that magically makes all the user code work, because magic. We'll start off with the gesture manager. So, start with the gesturable. So, obviously the user registers. All that does is create a registration command, which then registers you to the gesture manager. It then checks if that gesture already has a manager. If it does, it adds that gesturable to that manager. Otherwise, it creates a new manager based off of what type of manager the player said it is, and then creates that manager and adds it to it. So you register, checks if there's already one there. I have an assert to make sure the user actually sets up if it's a 1, 2, or 3 step manager, because if they don't, obviously I don't know what kind of manager it is, and I don't want it to default to a single, because then they might just get frustrated with why is it going only one? Why is it only doing it when I'm to the right? So figured it's easier to just tell them, hey, you got to tell me what this is. And then I also update the joints. So like I said, the user has to give me what joints they're using for that gesture. That way, instead of every frame redoing the math for all 25 joints, I'm only doing the math for the joints that the user is using for those for all the gestures that they want. So all this does is it gets that gesture that I've loaded from the gesture manager. I then get the joint list from that and add that to my own list in the manager. so that I can calculate those joints. I then have the deregister, which just removes a marker. Process elements processes the joints, so that goes through my list of joints and sets up those and does the math to set up those joints. And then I check the gestures through all of my managers. Here's the process joints. This just gets the joints from the gesture and adds it to my list. And this is just the deconstructor. The deconstructor does work. I'm deleting correctly still. So if we go up here, too far. Gesture test managers being deleted, as well as all of the single gesture managers for the 4 gestures that I've created. So, other than that, so the next thing to look at would be this is the test manager, and we've gone over gesturable. So next would be the single gestures. So there's the single gesture manager base, which is all it is a check gesture, get gesture, add marker, and remove marker. And then it also has a virtual deconstructor because obviously they needs to be able to delete all these managers specifically. So single gesture manager, this is for a single step gesture. When you create one, it adds whatever gesture you've passed in with its command for the first gesturable to be added to it, and it sets its gesture to be whatever gesture it's passed in to create. Then check gesture just checks if that gesture is completed along with the joint points that I have set up. And if it's true, it calls the execute on the command for that gesture. Other than that, I can get the gesture to check what gesture it is. Add marker simply just adds one to it, and remove marker removes a gesturable from the manager. And then I have my delete, which just goes and gets rid of all the gesturables that are in the manager. The same goes for the 2-step, but the 2-step right here, check gesture, obviously is checking if the first gesture is completed. It then sets an end time, and if this end time is equal to the current time plus whatever time the user's defined. So then if the end time is less than the current time, it will keep checking this. Otherwise, if it's greater than, it will move on to the second test, which will then check if the current time is less than the end time and if their second test is correct. If it is, then it will go through and it will call execute on all of those managers, or on all of those commands, as well as setting the end time back to 0. The same goes for 3, just has another step. So this one checks the first one's completed. If it is, then it sets the end time as well as setting test 2 to false. This is so whenever the first one's completed, it does not think that test 2 is already completed, because then it will then go on to check this one. So if this one is true and you still have time, then it will set test 2 to true. And then if you still have time and test 2 is true, then it will do the test for the third one, and if that is true, then it will call execute and set your time to 0. So those are the 3 types of managers and setups you can use for the connect that the gestures that I have set up. Other than that, the only thing that I haven't gone over is the connect manager. So the connect manager, this is what interacts with the connect itself. So we include Windows as well as D2, D1, and the connect file here. So to start off, we've got it's a singleton so that I can access it in my managers. But the so to start off, it has an update and it has an initialize. So the update is called every frame and the initialize is called once, obviously based on the name. Get joint points. This returns the D2 D1 points that I've calculated for the managers to use. setup joints simply sets up the joints that the manager, so the manager calls this to tell it to set up that specific joint, so that I'm only setting up specific joints instead of all 25 every frame. Then there is the connect information. So the in the setup you initialize the connect sensor, and then you also initialize the coordinate mapper. And then since I'm doing body data, I need to get the body reader, which is the body frame reader. And then this is for the getting the frame data. So I have a waitable handle, which is so I do not check all, I do not redo all the information unless there is new data that the Connect has. The iBody frame arrived event argument is the argument that is passed in with the waitable handle. This would return a frame of data if it comes true. The iBody frame reference is what I use to get a reference of the data that comes back from the argument, and then I can then from that get the iBody frame, which is actually the data of one body in that frame. Then I have my joints, and then I have my D2, D1 joints, and then I have a tracked boolean to check if a body is being tracked or not. And then I just have some private functions. Process body is to take the body position of the user. Like you could see before when I had the video up, it has my skeleton on more of a 2D plane. What process body does is it allows me to take the joints and put them onto a 2D plane so the user can check X and Y's against positions on the joints. And then I have a delete. Since this is a singleton, I need to have a delete function, and this is a template function which closes streams from the Connect. So everything from the Connect is a stream that you open and close whenever you need things. So what this does is it safely closes any stream that I give it. So it is a template class, so I can be like close this stream or this stream. I don't have separate functions. Inside the manager here, so we have our initialize. So this sets up null pointers for our connect sensor, coordinate mapper, and body frame reader. I then get the default sensor. So if you have more than one plugged in, it will just pick one. I don't know how it picks one, it just does. This also sets up the default connect sensor for you. If it fails, that means your Connect is not installed. Generally, since this is not a Windows app, it will just, the program won't run. So that is more of a thing for if they fix it. So if there is one though, it will have found an installation, which means it can set up body's frame source to null. It will open the Connect sensor, so it'll open the stream to the Connect. I can then get the coordinate mapper, get the body frame source from that Connect sensor, and then from the body frame source I can then open the reader of the frame source and get the body frame reader. From the reader I can subscribe to the if a frame has arrived by giving it my waitable. So this is what I use to check if the Connect has new data for me to be processing or not. I then release the body frame source because I don't need that stream anymore, and then I have a second check here just to make sure that the Connect has properly opened and everything is there, because if that's failed, that means that it couldn't open the Connect for some reason. So next is the update. So for the update, what it's doing is it's setting the body argument to 0, and then I'm asking the Connect to tell me if, so I subscribe to this for whenever something new has arrived. So I'm asking, has something new arrived? If it has, it puts it in here. That's what the get frame arrived does. So if it has, it responds to this with a succeeded. I then check if it's succeeded, because if it's false, I obviously don't want to do any of this. If it's succeeded, then I get a body frame reference from the argument that it gave me back. If I successfully can do that, which means that the data is not corrupted for some reason, I can then get the body frame data from that reference. So I can require the frame and the body frame from that. I can then get the bodies from that, I can process the body data for those bodies that are available in front of the Connect in that frame. I can then process the bodies if I successfully find a body. It will then process a body, which means I am going to go through that body and figure out if it's being tracked. And if it's being tracked, I will get all the joint information from that and put it into the array that is not on a 2D plane. That is like the Connects data version of that body's joints. So that's kind of like just putting an array on into something I can access. I then release the bodies, the body frame reference, and all that, because I don't need that anymore for the rest of the frame. And if I leave it open, it just slows down the stream. So next, I have the setup joint, which is just called by the manager to say set up this joint, because I want to be able to access that joint later. Body to screen is what is used with the coordinate mapper to push a body onto a 2D flat plane, so that the user can easily just check X and Y for a gesture to be completed. Get joint points just returns the joints. And then I have my deconstructor here, which calls the safe release on the coordinate mapper. I unsubscribe from wanting to know about the body frame arrived, and then I close the Connect. And release the Connect sensor stream. And then obviously I have a delete here, which is also being called to make sure everything gets closed down properly, because it is a singleton and it is right here. So, yep, that is the Connect stuff. Yeah, I mean, the user, I've tried to make it as simple as possible for the user. I created different types of gestures, which was kind of a goal I wanted to have. Instead of just having a single type of gesture, I have multiple types of gestures that the user can create. They're all simple to create though. But yeah, I mean, the only things I didn't get around to is I wanted to have some kind of like visualizer or something to show that the Connect is working properly, because obviously if a user doesn't have the SDK installed and doesn't have this Connect Studio, it's hard to visualize how the Connect sees you. However, that would involve opening a whole other stream of information and figuring out how to access all the information, and I just didn't have time to do that, so that was just kind of out of scope. But other than that, I think I hit all the marks I wanted to, and it seems that it works fast, and I tried to make it efficient as possible. The Connect runs around 30 frames a second on any computer that I've put it on, because all the computers I have been running on run at 60. And if you look at the update, I've got some debugs here just to show. But the Connect frame arrived only happens about every other time that Connect update is called, sometimes even more in between. So it's not the fastest at coming in, but it doesn't seem to be slow when you're actually playing or anything like that. It never seems like it's lagging behind, so thought that was pretty interesting about how fast it is, considering I remember when we were talking about it initially, you were saying a lot that there's issues with it, like lagging behind, and trying to keep up with it is hard. So yeah, I mean, what I've learned from programming on this is that like it's just getting information from like a external device is just a whole nother level. Trying to like set up all the ways that they have things set up and not knowing anything about it is just so out there. And I don't know, it was really interesting to learn about how Connect uses like a stream of data that comes in and out, and you have to constantly be opening and closing it, and how and learning about all these, whatever these things are, these HR results that I've never even heard of. So learning how that works and all these other Windows points and things that they use, it was all actually, it was interesting learn about it all. So a lot of research went into that, which is it's definitely been helpful to do this project, because I definitely learned to really have to dig deep on the internet to find something. It wasn't like I could just Google and it would come up immediately. I had to actually kind of like dig to find exactly what I was looking for, because there's not a lot of people out there doing work on this right now. So because it's still fairly new, still be on Windows with it. So yeah, it was definitely an experience, and I'm glad I now have experience with the Kinect. So if anybody ever wants to make a Kinect game, I can be like, hey, I have experience with that. But yeah, that's all I got for Sprint 9. If you have any questions about it, I mean, I'm sure I'll see you around. So, yep, that's it.